August Friedrich Leopold Weismann was one of the most influential biologists of the 19th century. He is best known for developing the germ plasm theory, a foundational idea in genetics and evolutionary biology. Weismann's work fundamentally changed how scientists understood heredity, development, and evolution, and it helped disprove the long-held belief that acquired characteristics could be inherited. His ideas laid the groundwork for modern genetics long before the discovery of DNA. Birth and early life. August Weismann was born on January 17, 1834, in Frankfurt am Main, Germany. He grew up during a period when Europe was undergoing rapid scientific, political, and social changes. From an early age, Weismann showed a strong interest in nature, science, and observation. His family supported his education, allowing him to pursue academic studies that would later shape his scientific career. Education and medical training. Weismann initially trained as a medical doctor, studying medicine at the University of Göttingen. He earned his medical degree in 1856. Although he completed medical training and practiced briefly, he soon realized that his true passion lay not in treating patients but in scientific research and biological theory. This shift from medicine to biology was crucial, as it allowed him to focus on fundamental questions about life and inheritance. After leaving clinical practice, Weismann devoted himself to research in zoology and evolutionary biology. He became particularly interested in developmental biology, studying how organisms grow from embryos into fully formed adults. His early research involved insects, especially butterflies and flies, which provided ideal models for studying variation, reproduction, and development. Influence of Charles Darwin. The publication of Charles Darwin's On the Origin of Species, 1859, deeply influenced Weismann. He strongly supported Darwin's theory of natural selection and became one of its most prominent defenders in Germany. However, Weismann was not satisfied with Darwin's incomplete explanation of heredity. He believed that understanding inheritance was essential to strengthening evolutionary theory, and this belief guided much of his later work. Professorship at the University of Freiburg. In 1863, Weismann joined the University of Freiburg, where he would spend most of his academic life. He later became a full professor of zoology. Freiburg provided him with intellectual freedom, laboratory resources, and students who helped him develop and refine his theories. His long tenure there allowed him to work deeply and consistently on heredity and evolution. Germ plasm theory. Weismann's most famous contribution is the germ plasm theory, proposed in the 1880s. According to this theory, hereditary information is transmitted only through germ cells, sperm and eggs, not through somatic, body, cells. He argued that changes occurring in the body during an organism's lifetime cannot be inherited by offspring. This idea directly challenged the traditional belief in the inheritance of acquired characteristics. Rejection of Lamarckism. At the time, many scientists still believed in Lamarckism, the idea that traits acquired through use or disuse could be passed on to future generations. Weismann strongly opposed this view. To demonstrate his point, he conducted famous experiments in which he cut off the tails of mice for several generations. Despite this, the offspring were always born with normal tails, providing strong evidence against Lamarckian inheritance. Weismann introduced the idea now known as the Weismann barrier, which states that information flows only from germ cells to somatic cells, not the other way around. This concept became a cornerstone of modern biology. It helped establish a clear separation between heredity and environmental influence, reinforcing the idea that genetic information remains stable across generations. Contribution to evolutionary theory. By clarifying the mechanism of inheritance, Weismann strengthened Darwin's theory of natural selection. He argued that variation arises in germ cells and that natural selection acts on these inherited variations. His work made evolution more scientifically rigorous and shifted biology toward a gene-centered understanding of inheritance, even before genes were fully understood. Later life and retirement. Weismann retired from teaching in 1912, but he continued writing and reflecting on biological theory. Even in his later years, he remained intellectually active, revising his ideas and engaging in scientific debates. His later works emphasized the philosophical implications of biology and evolution. August Weismann died on November 5, 1914, in Freiburg, Germany. His death came at the beginning of World War I, a turbulent time in European history. Despite this, his scientific legacy endured and continued to influence future generations of biologists. Scientific legacy. Weismann is remembered as a founder of modern genetics and developmental biology. Although he lived before the discovery of DNA and chromosomes, many of his ideas were later confirmed by molecular biology. His rejection of acquired inheritance anticipated key principles of genetics, making his work remarkably forward-looking. Today, August Weismann's theories are taught in biology textbooks around the world. His germplasm theory helped shape the modern understanding of heredity, evolution, and reproduction. He stands alongside Darwin and Mendel as one of the most important figures in the history of biological science. Conclusion. August Weismann was a visionary scientist whose ideas transformed biology. Through careful observation, experimentation, and logical reasoning, he challenged outdated beliefs and introduced concepts that remain central to modern science. His life exemplifies the power of critical thinking and dedication to truth in scientific discovery.